This video will show you how to input 10x Visium data as produced by spatialRanger into spatialGE, the web application. spatialGE is an open-source point-and-click tool to perform spatial analysis of spatial transcriptomics data. You don't need programming or coding to use spatialGE. We will start by searching for the 10x data repository. Then, in the search box, we will search for invasive ductal cancer breast Visium. Then we will click on this, and this dataset. Of course, you don't have to use the same datasets. You could search for other datasets here or even use your own data. So, as an example, we would click on the first one. Heads up here, it is possible that you are required to register for the website before being able to download. This registration is also free. We will scroll down to the bottom of this page, and what spatialGE needs for the case of Visium data are these two files: the filter H5 file and the spatial imaging data folder. Notice that the spatial imaging data folder might also contain the stained tissue image and a JSON file with information to match the spots to the tissue image. These two files are optional for the analysis. Let's create a folder with 3 subfolders where data for each sample will be stored. Here, notice that the spatial imaging data folder is compressed. We need to decompress, and in Mac OS, you can do that by double-clicking. This produces a folder called spatial. Now we go to spatialge.moffitt.org in the web browser, and assuming we have already signed up, we click here on Sign In and enter our credentials. Once signed in, we are taken to the My Projects page. Extensive documentation can be found here in the upper left part. Now we click in the New Project button, and here we select Visium in the first drop-down menu. Notice that spatialGE can also take data in the form of tables with gene expression and cell or spot coordinates. This is what we call the generic format, but this will be a topic for another video. We now give a name to the project and a description. Then finally click on Create. We are now ready to start importing data for each sample. 2 options are available. We can click on the squares to locate the files, or we can simply drag and drop. We start with the H5 file, which goes in the gene expression box. Within the spatial folder, we find the tissue positions list.csv file and drag it to the coordinates box. Since we have a tissue image and a scaling factor file, we drag them to the respective boxes. Please note that there are 2 image files in this specific dataset. We recommend using the high-res version output by spatialRanger. Then click on Import Sample. Now we click in the Add New Sample button and repeat the procedure with the other samples. Now that the 3 samples have been loaded, we proceed to add metadata. This is an optional step, but here we will add a single metadata column as an example. To add a metadata column, let's click on the option to add metadata manually button. Then we click on the Add New Metadata Column button, and here we will call this column Source and add the values for each sample. In this case, we know that one of the samples come from the FFPE protocol and the other 2 come from the fresh frozen tissue protocol. Then we click on the Metadata Complete button. Please note that we can also upload a CSV or Excel file. This file should have the sample names in the first column and the metadata in subsequent columns. Finally, we click on Import Data. This is a quick process, but there is an option to receive an email notifying when the process is complete. Now we can proceed with QC and data normalization, which we will address in another video.